Integration by parts, brought to you by Michaela Kuntz. Now in this video we will be going over the proof of this and the three different types. The types are substitution, continued substitution, and forming like terms. Now over here we have the proof of this. When you have uv as your function, you do the derivative of uv equals u times the derivative of v plus v times the derivative of u. Then you want to separate the equation out and then integrate each side. So you get the integral of u times the derivative of v dx equals the integral of d times the quantity uv times dx minus integral of v times the derivative of u dx. Now all the dx's on the bottom cancel out with the dx's on the integral. So you find yourself with the integral of u dv equals the integral of the derivative of uv minus the integral of v du. Now right here where we have the integral of a derivative, those will cancel each other out, so you're left with the integral of u dv equals uv minus the integral of v du. This final equation right here will be the one we will be using for the rest of this video. Now go ahead and pause the video and take notes on what just occurred. So we're going to work on substitution. We're going to evaluate the integral of x sine of x dx. Now, when we integrate this integral, we have to choose which function, the x or the sine of x, to be u or v. Now, I'm going to choose u to equal sine of x, which makes du equal cosine x dx. Then that means dv is going to equal x dx because that's what's left over in the integral. So v will then equal, anti-deriving it, 1/2 x squared. Now using the equation, u dv equals uv minus the integral of v du, we find that the integral of x sine of x dx equals u, which we said was sine of x, times v, which we said is 1/2 x squared, minus the integral of v, 1/2 x squared du, which will be cosine x dx. Now, with this equation that we just found, this integral is worse than that integral, the one we started with. We want the integral we find to be simpler than the integral we started with. So we chose wrong on the u and v. So therefore, we're going to have to start again. So now, we're going to have u equal x. So du will then equal dx. And dv is going to equal sine of x dx. So therefore, v, when you anti-derive, is going to be negative cosine x. Now again, when we plug this in, it's going to be integral of x sine of x dx equals u, or x, times v, which is negative cosine x, minus the integral of v, which is negative cosine x, times times du, which is just dx. Now, this integral right here is a simple integral which you can find the answer to easily. So it's going to equal negative x cosine of x minus sine of x dx. Actually, we'll be pulling this out, so that's a plus. So it'll be plus sine of x dx. And then, don't forget the plus c. Now, I want you to go ahead and pause this video and do exploration 1 on page 346. Now we will be doing continued substitution because sometimes just plugging in one u of v doesn't quite work. You have to keep going. So we're going to evaluate the integral of 2x squared times e to the x dx. Now when we start with this, you have to again choose which will be u and which will be v. I'm going to choose u to equal the 2x squared. So du will equal 4x dx. And dv will then be e to the x dx. Therefore, v will equal e to the x. So using the formula, integral of u dv equals u times v minus integral of v du. So, integral of 2x squared e to the x dx equals u, which we chose to be 2x squared times v, which is e to the x, minus integral of v, e to the x, times du, which is 4x dx. Now, we can actually pull out this 4 to be here because of the properties. And then we have the integral right here to be 4 e to the x times x dx. So with this one, we need to do u and v again. So the u will equal x. So du will equal dx. And dv will equal e to the x dx again. And v will therefore equal e to the x. So now we pull off what we had earlier. So the integral of 2x squared e to the x dx equals what we found earlier. So 2x squared e to the x minus 4 times the u x times v e to the x minus the new integral of v e to the x du v to the x. So this ends up equaling 2x squared e to the x from right here minus 4 times x to the e to the x plus, because of this minus right here and this minus right here, 4 times the derivative of e to the x plus your c. Now again, I want you to pause this video and do exploration number 5 on page 346. Now, forming like terms. Sometimes doing the u and v substitution just doesn't work. You never forget a simpler integral and you just got to keep going. So instead what you want to do is make another integral like the original and combine the like terms. So we will be evaluating the integral of e to the x sine of x dx. Now, we're going to start off with u equaling e to the x. So du equals e to the x dx. And dv equals sine of x dx. So v will equal negative cosine of x. So integral of e to the x sine of x dx using the integral of u dv equals uv minus integral of v du, we find that u equals e to the x times v, which is negative cosine x, minus the integral of v negative, which I'm just going to pull the negative out now and make this a positive, cosine x times du, which is e to the x dx. Now with this integral right here, we're going to do continued substitution again. So u will equal e to the x, du will equal e to the x dx, dv will equal cosine x dx. So v will then equal sine of x. So again, we use the integral formula to find that little integral right there equals, we're going to start from the very beginning again. So the integral of e to the x sine of x dx equals negative e to the x cosine x plus e to the x plus u e to the x times v sine of x minus the new integral of v sine of x times du e to the x dx. Now you might notice that this new integral that we just found is the same as the integral we started with. So what we are going to do is combine those two integrals together, combining the like terms. So it's going to be 2 integral e to the x sine of x dx equals negative e to the x cosine x plus e to the x sine of x. Now to get rid of the 2 and get the integral again by itself, you're going to divide both sides by 2. So the integral we started with, integral of e to the x sine of x dx equals the whole quantity, negative e to the x cosine x plus e to the x sine of x divided by 2 plus c. Now again, I ask that you pause this video and go ahead and try exploration 17 on page 346. I know we've already done a few examples, but here's another one. We are going to antidifferentiate ln of x. Now, the integral of ln of x dx. U is going to equal ln of x, and du will equal 1 over x dx, and dv will equal dx. So therefore v will equal x. Now, the integral of ln x dx equals u times v, so x times ln of x minus the integral of v du, so x times du, 1 over x dx. So that is going to equal x times ln of x minus the derivative, the integral of dx, because x times 1 over x will cancel each other out. So that'll equal x times ln of x minus x plus c. Now thank you for watching my calc video.